Okay, so just last week, I'm gonna get rid of myself for a second here. Just last week, I was working on a brainstorm for biomimicry 3.8. And I had to come up with all the biology all by myself. And so I was given a challenge and a series of like limitations and boundaries and like what they were looking for and what their time period was. And it was my job to find all of the different organisms that might be relevant and then whittle that down with a couple of people and pick the best champions from that list, while also having a really large amount of diversity within the organisms that I was creating. And so that sort of delves into some scientific research. And so I'm going to show you kind of how my brain processes this and how I do some of this stuff so that I'm getting a really diverse group of things. So the first thing that I do, and you'll see this map right here, a lot of times this is not something that I will do in something like Mural. Maybe I kind of sketch something out real messy in a notebook, but a lot of times I'm doing this in my head. And because I'm a non-linear thinker, I can kind of naturally bounce around and, make myself a little chicken scratch note and then be able to populate some sort of document or something, and I'm good. So let's say, so I'm going to take something that we started the last few weeks just so it's a little bit more comfortable for everybody. And so let's say I was given a challenge and I knew that I had to do something around navigating and senses and sensors and feedback loops and figuring out how to get from point A to point B and communicating that and sharing resources, all the stuff that we did with superorganisms. And so let's say I had to do a bio brainstorm on that for another company. Well, the first thing that I want to do is kind of wake up my brain and make a bunch of connections to some things. I wrote in there like flex those muscles, like your neural pathways. The more you use a certain path, the faster your brain becomes. And so, just to kind of get my brain in the right mind frame, this is the sort of thing that I would do. So and I wrote this, kind of jotted it down real messy in my notebook as I was picking this apart, and then I made this for you. So first it says navigation and senses. And so the first thing that I did was think, well, why are we navigating in the first place? What are we using this for? And I thought, okay, I'm avoiding detection. I'm getting around to do that. And then there's all these other things that are kind of related to migration and to also smaller navigations. And so if I need to navigate and I need to use my senses for something, maybe I'm finding food, maybe I'm finding a mate, maybe I'm finding my way back home or a short-term shelter. Maybe we talked about beehives just a little bit. Maybe I'm tasked with finding a brand new home or, like army ants, they have to find a place to kind of settle that queen in before they create a new bivouac for the day. Maybe, again, kind of like the ants, they're finding family. And so I was like, okay, I've got lots of different purposes where I might need to navigate. And then I was like, you know what? A lot of that has to do with migration. So I thought in my head, that is something that I might want to think about when I start doing my research. And then I always think about these two things. What's my time frame? And so, because I'm trying to link the organism or the system to the challenge, I want to think about what is going to be most useful for the environment where I'm actually doing the design. So I know that I could have some cyclical things. Some things I'm going to be using daily or hourly. And that even is true with migration. A lot of us, when we think about migration, we think about like those really long, huge journeys from one part of the planet to another, like, the monarchs and the geese and all that stuff. But that's not always true. There are lots of examples of migrations that go from like the bottom of the ocean to the top of the ocean and cycle back down within a day. Seasonally, those are easier. Generationally, that's something that we have with monarchs. So I'm thinking about already what are the different sort of scales and what might make the most sense for my company. And then another thing about time frame, which is kind of the opposite of cyclical, is this a result of dynamic non-equilibrium? Now, we do know obviously that there are some cycles in nature. We have a monsoon season, usually fires where I am in Colorado tend to happen in the same couple of months. And so these could be related, but I've just separated them for ease. So I'm just, again, like, how am I moving based on, a forest fire, for example. Like there's a couple of beetles that can only mate when they are in kind of like a burnt down log sort of situation. It's a type of jewel beetle. And so they have these like infrared sensors where they can tell where a fire is from like miles and miles and miles away. And they all sense that and they all congregate and they all make babies and whatever. So I'm already just thinking about like, what are all these different sensors that they might have? Again, that connects me back to thinking about scale and size in a couple different ways. Am I thinking about the size of the organism? Again, like a tiny little monarch, or maybe it's, some sort of tiny little oceanic creature that's making a vertical and then, up and down sort of migration. And then I'm also thinking about, so these two are pretty highly related, how large of a movement is required. So if I'm thinking about what my company is saying, maybe it's just the tiniest bit of movement because they're looking at something within a human body and they're trying to do some navigation and some data collection inside of a human body. Or maybe they need some sort of like multi-country level satellite out in outer space sort of thing. Now some of my animals and organisms and stuff might be scalable and some of them might not. So again, I'm just throwing out everything that would be going in my brain so I can make a ton of connections. So when I actually start gathering different organisms, I've kind of like woken up my brain a little bit. Obviously, we got back to this, navigation senses has a lot to do with communicating with others. Not always, if you're hunting, you might not be communicating with others so much. And in other cases, like when you've got all the female lionesses, we are. So then I thought about, okay, what are all the functions that could relate to these purposes so that I could maybe, and one of the other points of doing this, aside from waking up my brain and making those connections and getting my neurons firing, is to also generate keywords. Because that's going to be really important when you're finding the right research, is knowing what words to put in there. So I was like, okay, related functions. I've clearly got travel. I have some sort of movement. And remember, like, even our most mobile of organisms might still move a little bit. Plants can face the sun. So again, thinking about scale and size, time is, a piece of that, which I also have over here. So am I in a gas? Am I in a liquid? Am I in a solid? Multiple. If I'm trying to figure out navigation, well, I have to know where am I now? Which direction am I facing? And where do I need to go? So those are two completely different things that I am going to need to know before I go anywhere. Again, and this is more in terms of migration, but if I'm finding food or something, or if I am trying to find my way back to the lair, I need to be able to know this. And then these are things we've talked about already. I need to send signals. I need to sense signals, and I need to be able to respond to them. And then maybe I'm the one to send the next signal for someone else to sense, and then respond to. And then here, because I'd already considered dynamic non-equilibrium, and I'm already thinking about cycles and seasons and size and all these things, then I'm kind of, again, coming back to the idea of the operating conditions a little bit. So if I'm sensing these signals, or if I'm sending signals, well, what could I be experiencing that's going to allow what I do next? So we know we have environmental cues. So again, if I'm thinking about dynamic non-equilibrium, that could be like smoke, and I'm picking up on that, just like the jewel beetle I was just talking about. And it could be biotic, other species. So for example, I think I mentioned this before, how the acacia trees, when they start being nibbled on by a giraffe, they can put these like chemical signals into the air, which are then read by other acacia trees, who then altogether they can start making tannins, which in their leaves make for just like horrible bitter taste. And then like, the giraffe will go from the next one to the next one, and they all taste terrible, and so they leave. So it could be something from the same species, or it could be something from another species of communication. So again, I would probably just kind of make a mess out of things like this on, a notebook paper, and then start kind of moving from there. Now, the next step, and here's where I can use, I'll have you guys populate some of this with me. Again, if I'm thinking about background knowledge, What are the senses and signals and responses that I already know that then maybe I can look for like bigger patterns and stuff later? So, of all the different organisms that we've talked about, how are they communicating? So, I'll give you a second to think of an organism, or even it doesn't even necessarily have to be that we've talked about. How are they communicating with each other? And if you can write the name of the organism as an example. And we also know that, organisms use multiple things. Right. And it's okay if we've got a few of the same thing. That's totally fine for now. Think about ourselves. I see someone wrote down ants sensilla that have those all over their bodies. Think about other organisms that you know. What else has a physical structure that might pick up on a signal or produce a signal?
Does color come under light, or can it be a different
That could
thing?
be two different things. Yeah. It's a slightly different process, sort of. And also picking up on light and creating light are two different things. And then you also have like, infrared versus ultraviolet versus, what we consider visible light and color. So, that could all be picked apart. Okay, awesome. So we've already said, all right, here's some things that we are aware of. So this is often where I start if I'm making a spreadsheet or something. This is the first thing that I'll do is like write down the organism, write down the basics of what I know, just so I can, again, like just kind of barf out everything that's in my brain. And so I would use this to populate, Google spreadsheets or Excel or Airtable or something. And then another place that I would start thinking of, and again, this idea of divergent thinking where I'm trying to go in multiple directions, when I'm kind of going back and forth between, some of my thoughts and my brainstorm and my different lenses here, that can also help me generate a more diverse list there. Now, so let's go to the next one for a second. Now, in some cases, when you're making a biomimetic design, sometimes the company that you're working with says, we have, this one product that we are making, and here's, where it's being used outside, mostly in the Midwest, blah, 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 blah. But sometimes we have, let's say, a factory, and that factory is located in, Australia, but then there's another one that they are putting in like northern Russia, and then maybe there's another one that's in Costa Rica. And so when you're searching for organisms, you might have to think of multiple different biomes that could fit those challenges too, based on, again, the scale, the size of the operation. Is it part of a system or a supply chain? Or is it just like a small product? So what I would like you to do here is just brainstorm a whole bunch of different ecosystems. And then if you will just connect with some of these yellow ones, I don't care how you organize it, a few organisms that would belong to that ecosystem. Again, just stretching my brain in a different direction. So I could have like, subterranean spaces, and then give me a couple organisms that spend most of their life underground, for example. We can get pretty specific. So tropical rainforest. When you say forest, what type of forest? Because I still have some variation there. Are we talking temperate rainforest? Are we talking about, high altitude alpine coniferous forest? Am I talking about a largely deciduous forest where I have, that sort of seasonal change all the time? Ooh, deep sea hydrothermal vents. Yes. Chemosynthesis down there. tube worms, and yeti crabs. Okay, I see ocean up there too. We have so many biomes within that. So a few of you can start picking that apart. All of these different ecosystems are going to have different operating conditions. Also, if you, whatever you double click next to, it'll create the same type of box. If you don't know that already. Do I have desert in there yet? I do. Okay, now remember, deserts can be hot or cold, so that can help you with organisms as well. So if you go up to, for example, like Mongolia, is that the Gobi Desert up there? Those would be organisms that you would also kind of categorize under cold desert. Okay. So this is looking pretty good. I'm starting to see like a lot of you populating with like different sort of marine environments. Okay, so now this is pretty good. If I can have some of you just to organize it a little bit better so that we have things in little chunks that we can come back to later. So it's an easier resource for everybody. And that's the nice thing about doing Mural as a whole. Everybody's brains. All right, I see the water people are grouping theirs together. Remember, open ocean is different from like the abyssal parts of the ocean, which are like the deepest down, which are different from estuaries or places where I have fresh water that meets salt water. We call that brackish water. Those are great places for biodiversity because you've got organisms who have to survive in salt and in fresh water. So that would be another great one. We also have, I see like coral reef up there, things like a seagrass ecosystem. Those work together. Mangrove swamps also work in tandem with coral reefs and seagrasses sometimes. I'll give you like just one more minute. Organize a little. You know, you could even consider invasive species that exist there and are thriving, but are taking over. Like that also works. Ungulates, awesome. Our prairies are the most endangered ecosystem on the planet. We all always talk about the rainforests and the coral reefs, and yes, those are also endangered too. But if you think about the prairie, if you've ever driven across mid-America, you don't notice a whole lot of animals. It's all farmland, 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 pesticides, herbicides. You know, diversity is a disaster. Okay, awesome. So again, the idea is divergent thinking. The idea is waking up my brain. The idea is trying to generate a whole bunch of keywords so I'm not stuck in like one way of thinking. So again, I might, like, I don't know if you guys have ever seen behind me, but I have like a giant whiteboard in my office and I put sticky notes up there all the time, just like a little mural, because I like working on paper. So I will do something like this because, and I think we talked about this earlier too, when I'm comparing the operating conditions of whatever the product or the factory or the mall or whatever I'm making is going to be, sometimes I have ecosystems that are totally different, but deal with something specific. So if I have, a mangrove swamp, or if I have a temperate or a tropical rainforest, I know dealing with large amounts of water, I'm going to find a ton of strategies there. But if I look in the desert, which typically we would not think of at all, well, they also, like if I think about Phoenix, you also have that monsoon season down there. And so we have a ton of water all at once. And so those organisms still need to be able to deal with that. The time is different, the cycles are different, the scale is different, but they still at some point are dealing with this giant deluge of water. And so that's also one of the reasons why I might, I'm not going to brainstorm something quite as huge as this that you guys just generated, but I'm going to be thinking about those various ecosystems where there could be overlap of function in terms of dealing with a specific example of dynamic non-equilibrium or seasons or whatever. Okay, great. So let's go. And so again, you'll see there's this little arrow connecting this over. All right, so we're going to move on for that. I've got my initial brainstorm. What do I already know? Now I'm thinking about operating conditions and organisms and stuff. And now if I'm learning something kind of new and I want to sort of start digging into stuff that's beyond my scope, and I also want to start looking for mechanisms. I'm going to kind of, and again, I'm doing a lot of this in my head. I'm just kind of metacognating it for you so you can sort of see my thought process. So let's say I'm looking for mechanisms. I know that, echolocation is a thing. I know the sound goes out. I know the sound is red, but I might not know the mechanism of that thing. How are they creating the sound? And when it comes back to them, what is actually happening structurally to cause that? And so when I look at this, I always start with stuff that's for kids. If I'm trying to build my background knowledge, I'm going to start with things that are visual. I'm going to start with, diagrams and all of that stuff because I'm trying to build myself a general baseline. And so now I'm kind of going from scoping, where I'm understanding the challenge itself and brainstorming kind of what I know already that fits in with that scoping. And now I'm really getting into discovery. How do those organisms I already know do the thing that they do? And two, what are some different organisms I didn't even think about that might help? And thinking about scale, thinking about a whole system. I see some of you wrote like everything from like bacteria to an elephant and larger. So what I am going to classify this, and hopefully some of you have come across this, middle school, high school. I'm going to start with the tertiary stuff. Google Images, kids videos, YouTube, sometimes Wikipedia. Then I'm going to go to secondary stuff. So I've got a decent grasp on it. And again, I'm looking for things that I don't know yet, like the mechanisms. Then I'm going to look for popular science websites, books, things with more reputable, hopefully less biased sources, but I'm always checking that. And finally, when I've like, okay, I have a really strong sense of it, from there now, I'm going to go into the primary lit, where I can really, really uncover like the exact primary, like what do they do? How do they figure it out? What is the data? What is the tiny little structure? What does that sensilla look like? What's happening on a molecular level? How does that structure work in terms of like the physics behind something? Yeah, why I start with Wikipedia a lot too. Yes, and Jade, that's awesome. So Jade mentioned that if there's a good article, whatever they've cited above, they have those resources at the bottom. So I do that all the time too. I might start something on Wikipedia and then I'll go to the very bottom and I will go straight to the primary source down here. So the thing I would like us to do right now is start giving me examples of what some of these things might be. Again, we're kind of building a class compendium to help other people. So what are examples other here than tertiary, secondary, primary? Like where would you look? What could this be? All right, so something like news sites, give me specific ones. TV shows, yep, that's a good one. And that can sometimes span tertiary and secondary. Pardon the noise, my husband is taking out our beast pup right now. Yep, documentaries, that could also fit in secondary as well. I also in tertiary, I might put stuff like kids books in here. What is that series where like on the front cover, it'll say like archaeology or Egyptology or whatever. And then it has like a ton of different pictures. I can't remember if it's DK or what the publisher is, but I think all of us read them as kids, like shells. And then like we read the whole thing and we get like obsessed over it. Yes, Scholastic Book Fair sort of stuff. Yeah. Tertiary, that could also be a podcast. Same thing with secondary, that could be a podcast too. In some of these instances, you might get a little bit of the primary. If you are maybe having an interview with someone. So some of these things, might be found in all three. So I want to come back to secondary for a second. I see Science Daily in here. That's awesome. What are some of those other magazines or sources that would be reliable? So for example, nope, I don't want that one. Yeah, Scientific American, that's a great one. So something like, National Geographic would be another one. So specific. If you think of a TV show or a documentary, who's producing it? What could be like, is it a series title that you can come up with? TED, that's awesome. Okay, now over here, there are also other types of journals that we can specifically look at. One for biomimicry is called Zygote Quarterly. If you have never looked into that one, and I didn't know about it before I did my master's degree, that is an awesome place to just every once in a while go to, because they have just the most fantastic up-to-date things that can directly relate to biomimicry. Crash courses, awesome. Yeah, specific YouTube channels in particular, awesome places to study. And then you have things like computer. You also have like scientific places that, oh my goodness, are like compendiums of where papers are sort of stored. So you might have something like this. Or you might have something like NASA. Okay, so we're going to pause there as or if new ones pop into mind. Great, awesome. So I'm already seeing pros and cons, fantastic. This is great. This is not as accurate. So that's something that we want to know about models. If someone is modeling something, whether it's an analogy or something physical, it's usually looking at, one thing is great, but something else has been compromised. So it's not maybe as accurate, but it's helping you get the broad strokes. It's an introduction. Oversimplification, great. Where does bias fit in? If you're going to write the mitochondria as the powerhouse of the cell, I'm going to throw up a little. Yeah, and the not able to be cited, this can be there too. Yep, technicality here. Also, think about the visuals that you would see. So when I'm looking at primary literature, a lot of times I can see like the SEM pictures of things, like those really extreme close-ups, and like that's the best place to look for it. Here I might have, like a simplified diagram. So great to start here and then like work my way up. Here, I'm also going to have a lot of data, which is kind of a pro and a con, depending on like how experienced you are at looking at graphs and data tables and all of that stuff. Okay, awesome. I think most of us probably naturally, depending on where our experience is and where our background knowledge is we're probably going to bounce around a little bit between all three of these. Again, like that makes sense, depending on your background knowledge. I mentioned bias. Again, hopefully that's something that you guys have talked about a gazillion times up until now. If you find some information that you think, oh, this is really interesting and this is really cool, but you're not totally sure if it's completely right or if there's bias or if it was funded by, the sugar industry or something, it's always good to include that, but like, have a little note on there that says, yeah, I don't know if this is substantiated. I don't know if there's bias here. Because that's something that, like, if it's really cool, maybe you can dig a little bit farther. All right, Ask Nature. And Ask Nature is going to have a lot of primary in it as well. They are going to have a blurb that someone from the Institute wrote, but they're also going to quote and link the primary literature in there as well. Okay, great. So what I'm going to have you guys work on now that we've put our brains through this whole thing and are kind of primed, here are what I'm going to have you look for Wednesday. I want you to find a variety of things about organism senses. I want you to focus primarily, we're going to get into the academic literature Wednesday. So don't worry about this stuff yet. I just want you to build your background here on the tertiary and the secondary. So we're looking at animal senses, we're looking at migration, we're looking at navigation, we're looking for stuff that we didn't talk about already. I want you to skim at least 6 articles or more, post your top 3. I do not want any repeat articles. I do not want any repeat organisms, but I will have repeat senses, which makes sense. So can have repeat senses, like that's going to pop up and that'll help us sort of find some patterns. After you've done that, and don't do anything yet, I'm going to have you vote. And so this would be a good thing to do, like, maybe Tuesday night or something when a whole lot's populated. Read a few of them, and then if you see one that you're like, this one's awesome and contains a ton of great information, you're just going to write like your name and like, 3 words about why you liked it. When you are all done with that, I'm going to zoom way up. There is one final thing that you're going to do for Wednesday. You see how it's all the way down here? This yellow way down here at the bottom. It's way down there so I could give you a ton of space to populate that. So when you're all done with that top process, you're just going to do one of these 3 things. You'll put your name. If you saw a pattern of various organisms that they all like, these used all of this, which makes sense because whatever, you could do this one instead. What do all the resources actually share, the good resources that they have in common, or a reflection on the process itself? If you have your own specific process for finding good information, or a place where you always start, or something like that. So self-reflection, comparison of resources, comparison of organisms, you just have to do one of those. If you want to do more than that, great, but just one. So I'm going to show you an example of how you could set this up, and then you will have the next chunk of time to populate this. So hopefully you don't have too much. Again, I do not want repetition of articles. I do not want repetition of organisms, but you can have repetition of the sense / the structure. And so let's say you're just, doing just a really broad scale example. So let's say, I'll show you an example of one. I found this one the other day. 20 things you didn't know about animal senses. I'm like, all right, it's Discover magazine. I think that's probably pretty good. That's going to be, maybe secondary, depending. It could be tertiary. So I see I've got just like a bunch of really short little facts there. So like this is a good introduction. I see I've got a whole ton of different organisms. So maybe this, links me to a different organism I might really want to look at. But I notice as I'm reading through here, it kind of talks about what it does and why it does it. So they're communicating to one another. They might have some sort of structure like the trunk or the feet, but they don't necessarily have the mechanism. So what I would do in this case, I would say, all right, let's say that was one of the best ones I found. And so that was called what? 20 things you didn't know about animal senses or whatever. Okay, now I'm going to click this. Here's the place to put the link, enter the link, and now I have that here for anyone else to read. Now, I am not necessarily going to pick all 20 different organisms that it listed. I'm going to maybe choose like the best one or two that I think are really interesting, or that maybe they hinted at the mechanism a little bit and I want to come back to it. So I might write, all right, I really liked the alligator. They use sensitive skin and they're kind of basically doing this. I don't know the sense name. They didn't tell me what that thing was. So I'm just going to kind of mark in there what I know and what I don't know. What are they using it for? Finding prey. I might also guess, well, if they're using their skin to detect vibrations, they're using it to find prey. Could they also use it to see who's coming that might want to harm their eggs? Maybe. So I'm trying to, again, broaden my ideas. Mechanism. Well, they didn't have that there at all. So I know that maybe, this is an article that's just all right, but I'm really going to look for another article somewhere along the way that has more of the mechanism, the how, the chemistry, the structure on a molecular level, et cetera, and then my name. So then from that same article, let's say if I saw, elephant was another one in there that I really liked, I'm going to write down that thing is, and then I'm going to call the day. And if again, I'm like, oh man, it didn't say the mechanism for this one either, and maybe it didn't say the sense name, or like maybe it missed something, you can kind of just like put question marks because it didn't say. And then the next person, okay, so I'm going to skip down so that I can show that this is all one article. And then the next person goes here. And then also, again, notice if you just click right underneath, it gives you a new box. If you right click and you can either link there. Actually, I don't think that's the right link. Never mind, ignore that. Left click here, and then you can put a link on there. So I'm going to give you time to start looking into things, skim a whole bunch of stuff, look for the mechanism. If you find a whole bunch that are really interesting and have good information, but they don't have the mechanism, then we're going to select from this list on Wednesday and start looking for some of those things more in depth when we get into the primary literature over here. But if you can find a couple mechanisms or even a hint, like, if they said something about the sensilla for ants, we've got a structure. And then if it says something down here about, like using fatty acids to like have some, chemical that combines with another, like it might hint at something on the how it works. For the how it works, you'll also see the words like by. They're doing this with this structure by doing this, or using this in a specific way. Okay, so again, once you've got a few and yours might not always all be like in line, that's fine. You also, this one isn't going to exist here because these two right here were from the same article. So just keep that in mind. You might have multiple things from the same article. Okay, so primary sources we're not going to deal with now. Just secondary and tertiary. Make sure that you link them. And I'm going to give you the rest of the time to find stuff about senses, navigation, communication. Just make sure that as you are scanning, that you do not have the same article or organism as somebody else.